So, I guess we are live. Hi everyone and welcome to the second day of the first ever Java Champions Conference. My name is Mattias Karlsson and I'm a JUG leader and Java champion from Stockholm, Sweden, and I will be your host and moderator for this session. The session is JSR381, Visual Recognition for Java, a friendly ML API. And with us to present this is Frank Greco. He's the founder and CEO of Crossroad Technologies. He's also a senior technology consultant and enterprise architect working on the cloud with AI tools for developers. He also a Java champion, chairman of the New York Java SIG, the first ever Java user group. And he also a guitarist in the band Null Pointer Exception. Hi, Frank.
Hey, Mattias. How you doing, everybody?
I'm great. And our second speaker for today is Zoran. He's an associate professor at the University of Belgrade. He's also a Java champion and artificial intelligence researcher. His main interests includes deep learning, software engineering, and Java technologies. He is an open source enthusiast and a NetBeans contributor. He's also the CEO and co-founder of a startup, DeepNet, which is building his next generation deep learning platform. And by coincidence, he also plays guitar in the conference band Null Pointer Exception. Hello, Zoran.
Hi, good to see you, Mattias. And you forgot to say that you play drums in Null Pointers.
Exactly, we could probably do a drumming session and a full session here with live instead. Yeah. Okay. Are you ready to go?
We're all set.
Please take it away.
Great. Thank you very much, Mattias, for the introduction. And hello, everybody. So what we're going to talk about in this session is JSR381 visual recognition for Java. And it's the two of us, my colleague Zoran and myself, and a host of others, which I'll mention in this deck. So next slide. It's us again, and of course we have to mention the null pointers, of course. I guess if I play bass, or you can play guitar, and Mattias can play drums, we can have we can do a gig right now. Next slide. So what we're going to do over the next 45 to 50 minutes is that we're going to take a step back, and we're going to look at machine learning in something very interesting, patterns and how it relates to machine learning. And we'll look at why machine learning is different than the programming that most of you have been doing for most of your careers, and see why is it different. Then we'll talk about Java and machine learning. You know, machine learning is not just all Python, so we're going to talk about Java and machine learning. And then we'll get into specifically the details of JSR381, which is visual recognition, as we affectionately call it, VisRec. And Zoran will then dive into the nitty-gritty of VisRec, the architecture implementation. And of course, we'll have a really cool demo and some code to take a look at. Next slide. So patterns and machine learning. There's a significant correlation between patterns and machine learning, which we'll get into. If you go to the next slide, please. Now, we've all heard about, machine learning, and we've all read the articles and how everyone's quite excited. But, in my opinion, this is just like these other discontinuities in technological progression, whether it's electricity or the printing press or even the creation of computers. Andrew Ng, who's one of the big names in machine learning, has said that machine learning and AI is the new electricity. So what he's saying is that this is a step up in our technical innovation curve, right? It's just a jump up. And when I first heard that, it was sort of like a little bit of a hyperbole. Okay, this it sounds like a marketing thing, but as I got more and more into it, I really, really believe that's true. This is a significant thing that not just all Java developers, but all developers. As a matter of fact, everybody, politicians, geopoliticians, average citizen, you should be all interested in this stuff, but we're the developers, so we need to be keenly interested in this. Next slide, please. So patterns. So this is quite interesting. So patterns are all around us, and I remember back in the day, going back to my graduate studies, I used to hang out in the computer lab. Back in the day, we used to go to a computer lab as opposed to working from our laptops. And I remember sitting down one of my favorite spots in the lab nearby a disk drive, and getting back then, disk drives made noises. And I would notice that there was a guy that came into the room, and he would sit in the back. And whenever he started programming, I would hear the disk drive make certain noises, certain specific noises. It would go zzz, 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 and I would notice that whenever he came in, the drive made that noise. And there were times where I would be engrossed in my code, and I would hear the noise, that same pattern, and I would turn around, look up, there was that guy in the back. And so it was like a joke to me. It's like I was able to predict the future. I was kind of thinking to myself, yeah, I can predict the future. Whenever I hear that sound, I knew that person was in the back of the room. So I sort of like had that, it's kind of like a laugh. But then I started thinking, as a musician for most of my life, besides being a techie, I know that there's patterns in music. And, if you're a guitarist, the upper left-hand side of the slide, what a 1-4-5 in blues is. So if I told Zoran, I said, Zoran, we're going to do a 1-4-5 in a key of A. He knows there's a pattern, and he knows how to predict the future. He knows what chords are coming. Or if you're a jazz guitarist, and I said there's a 2-5-1, and we're going to do it in C minor, you know what the next chord's going to be. So these are patterns, and you could take advantage if you know the patterns of your opponent, or like the bears there, they know the patterns of the fish. Why are they there? They're taking advantage of patterns. What if you're a sports person, like whether you're European football, or you're actually, I should say, world football, or American football, and you know the patterns of your opponent, you could take advantage of it for success. So I've sort of noticed that, and I also noticed that I went to school for astrophysics, physics undergraduate, and I know that stars go through patterns. There's a lot of stellar phenomena that go through patterns, like supernova, like when stars become unstable, when the chaos index goes high. And I'm sure as developers we know when the chaos index goes up, there's an explosion, and it comes back to a steady state. So there's a pattern. And that pattern, so I thought of that pattern. That pattern occurs in software development. That pattern occurs in business. When things are unstable, there's an explosion, and things go to not a literal explosion, hopefully, a figurative one, and we get back down to a more steady state. So, and this happens in business, and it happens in everything, right? So patterns are all around us. Next slide. So there's this gentleman, Norbert Wiener, who back in the 40s said that the world is totally composed of patterns. So he said this before the famous 1956 first conference on AI. So this was a genius observation. And to me, this is the start of machine learning and AI, is this gentleman in the 40s saying this. So I know that the first conference was at Dartmouth in 56, and there's the heralded group of 8+ truly smart people thinking about AI. But this gentleman came out in the 40s and said this. So this was truly genius. Next slide. And as software developers, we know about patterns, right? We've seen this book, whether it's in electronic form or on our bookshelves, we know design patterns. And even before design patterns, we heard of the term idioms. And idioms is a type of pattern, right? Style is a type of pattern. So this book itself is patterned on something. So next slide. That book was patterned on this book called A Pattern Language in the late 70s. So this book is not about software development. It's about architecture, physical architecture, building architecture, construction. So it's interesting that our software development patterns book is based upon a building architecture patterns book, which influenced, Ward Cunningham to do the first wiki, and influenced Agile. So there's patterns, right? Next slide. And also, when you learn a foreign language, you could learn it in two ways, right? You could go to school and learn all the rules, the algorithms for the language, so to speak, and you could study it for years, or you can do it in a conversational way. You try to listen to somebody and you try to mimic what that person's saying, and then you try to do it on your own. And if you do it incorrectly, the instructor would say, well, no, that's not quite correct. You should say it like this. And then you correct yourself. And maybe you make the mistake the second time. It's like, you got it almost right. Let me tweak a little bit. And then you get it right. So you constantly correct it. And it seems like you would learn faster. You don't have to go to school for 4 years to learn about the language. You can learn it from a conversational point of view. So traditional programming is like what's on the left, where we understand all the rules first. Machine learning is following patterns. That's more like on the right. Next slide, please. So where does this apply? It applies any place where you have a lot of data and a lot of parameters. So what does that mean? Next slide. It's all the hard problems in our world. Whether it's weather or it's cybersecurity, medical diagnosis, these are hard problems. Matter of fact, I talked to a colleague who's studying visual recognition of images, medical images, to detect COVID, and they're doing it for a very large German healthcare firm, and they're using machine learning to detect that. So there's a lot of areas where ML can be applied. Excuse me. Next slide. And even in e-commerce, we know that ML is used to detect patterns in how we do e-commerce, and also in other places. So it's whether it's language translation or it's in social media, it's all the harder problems, right, in life. Next slide.
So Frank, just hang on 2 seconds. Zoran,
Yes?
could you click hide on the stop sharing thing? Because it's
Okay.
Please continue. Sorry.
That's okay. Thank you. So that's a little background on patterns, and this is why I got so excited about machine learning. So I've been involved with patterns, whether it's in music or actually my master's project was looking at melodies and coming up with the style of the melody and then generating a new melody in that style. Well, that's a pattern. And I also, when I was at Bell Labs, I was interested in fractal compression, detecting patterns in images for compression. So I got really fascinated with ML because it extended my interest in patterns. So now let's take a look at ML and conventional programming. Next slide. So most of the program that we've done, that most of us have done, is this type, in this picture. Now, if you're into computer simulation and you know about financial models, you know about weather models, well, you can do a Sleep 300 right now. So I'm going to talk about to the people who don't understand that type of programming. Most of the programs we've written, when you think about it, when you go to solve a problem, you think about how a human would solve it, right? You think about how you would solve it as a human being, except you're going to give your algorithms to the machine and let the machine do it faster and more accurately. But you're thinking about it as if, how would you do it, right? It's really interesting, a phenomenon. So your programs are, typically a collection of if statements, sort of almost like an expert system, right? Traditional programming, you're writing if statements, go here, go there, go there. So that's like traditional programming. Next slide. Right. So then in traditional programming, as we know, you have data and you have a model. And the model meaning that when you're asked to solve a problem, you come up with either a physical or an abstract model on how you solve the problem, right? Collection of algorithms, something I'm going to use functional, I'm going to use object-oriented. You come up with a model how you're going to solve the problem, and you give that to the machine and you come up with a result. Now, next slide. Now with machine learning, it's different. You have data, right? You collect a lot of data, and you already know the results. So, like for example, if someone told you we need a program to figure out if people should get a mortgage, right? If they're qualified for a mortgage. Well, okay, so you have to look at if, like a couple has a certain income, what the house is valued, what the assets the couple has, where is the house located. So there's a lot of variables. And I just mentioned like 4 variables. There could be dozens and dozens of variables, or maybe even hundreds or even thousands of variables. But you know that when you have data that has these characteristics, the house is in this location, the couple makes this much money. When you have those results, you can predict the future. Yes, that couple should get a mortgage. They're qualified for a mortgage. So if you have unknown data, you feed it, and it follows those patterns, you know the result. So you tell the machine that I need to create a collection. I need to create a model, right? Use a collection of algorithms, an algorithm or a collection of algorithms to come up with the model. So it's a little different than traditional programming. So next slide, that you can see the comparison. It's a little different than traditional. So we know what the result is, and we just want the machine to give us our model. So that's the difference between traditional programming and machine learning. Next slide. So Zoran came up with this really nice diagram. So the way the basic workflow of a machine learning application, and this is something that all developers, you should look at this carefully. This is the basic high-level view of the workflow for any ML app. The first step, and it's probably the most important step, is preparing the data. This diagram is not drawn to scale, because that first phase is the big phase, right? And if you talk to any data scientist, most of the time of their day is spent in data prep, where you're gathering the data, you're organizing it so the machine could munch through it real quickly. You're cleaning the data, throw out the outliers. You're removing bias. Data prep is very, very important. Next slide. So then once you have, you're satisfied with the clean set of data. So now you pick an algorithm, right? You pick an algorithm, and you pick an ML algorithm or a collection of algorithms, and you say, I need a model. So you pick a model, and you train a model. You constantly train a model like with your data. So here's the data. Now look at this and test the model. And you test the model, and you kind of reduce the error, right? You kind of tweak it. And each model and each set of algorithms has a collection of parameters, right? And you constantly, this is the area where typically a data scientist spends most of their time. You're tweaking parameters until you're lowering the error, until you're satisfied with the error. So are you satisfied with 75% accuracy, 80% accuracy, 95% accuracy, 1%? So it's up to you. And then when you're satisfied with the lower error, next slide, is then you take, in our case, we're Java developers, we're taking a jar, or we're creating a containerized view or some service, and we put it into production. Next slide. So now let's talk specifically about Java, and machine learning. Next slide. So when I first learned about machine learning, I got this, thrown at me. Well, you can do machine learning in any language you want, as long as it's Python. So next slide. So being a Java developer, I said, well, how can this be possible? I mean, it's machine learning is a big field. So what's it about Python? Next slide. And it's not just me, right? There's 12 million Java developers out there. We're going to tell people that 12 million Java developers, no, you have to learn Python. You have to learn it well to do machine learning. It just didn't seem like the right thing. Next slide. So Zoran and I mean, years ago when we first met, we both thought we wanted Java to be a first-class citizen. And certainly Zoran will dive into this more in detail in his section of the presentation. But, we didn't want another, what we kind of jokingly say a JavaScript doomsday scenario. So where we had the web, but you only had one language to focus all of your creativity, to express all of your creativity. And Python is a very good language. I mean, it's a really good data scientist language, right? But there should be other languages to express your creativity. And the existing APIs, and again, Zoran will go into this more detail, but they just weren't Java friendly, right? And they were really for data scientists. Next slide. So we thought, like, well, we're not the only ones. Let's reach out to all these, big companies and say, who's interested in Java and ML? And not surprisingly, we found that all of these companies were very, very interested. From Google, Oracle, IBM, Azul. We talked to all these people, and Twitter. We talked to all these people. They were all interested in how do we use Java more for ML, and even talking to Brian Getz. And one rainy day in New York about ML. So next slide, please. So now let's specifically talk about JSR381. Next slide. So we started a couple of years ago. It was Zoran and I, and we started with JSR381, again, as we affectionately call it, VizRec. And we were joined by Kevin Berenson from Open Value, who really helped with some of our coding. And we started off with the submission to the JCP for visual recognition for Java. Next slide. And we had a lot of advice from senior people, all these people that on the slide, and many others gave us advice on how to tweak the API for practical use. Next slide. So now let me turn it over to my colleague Zoran to talk about specifically about the API and the architecture. Zoran, it's all yours.
Thank you, Frank. So the main idea behind JSR381 is to create a Java developer-friendly API for computer vision tasks and machine learning. So why we have chosen the visual recognition? Because it is very hot topic, and it has many interesting real-world application, and we could say that it is one of the main driving forces behind development of modern machine learning and deep learning. So the idea is to pick one application domain, but to create also a generic machine learning API that can be applied in other domains. And one of the main points and main ideas is to design the API specifically for Java developers. So anyone knowing how to code in Java could really very easily can pick up the API and start doing something practically without having to dive deep into the theory behind machine learning. Next thing is to allow multiple implementations. So the API should be extendable, so different existing machine learning libraries should be able to implement API, and it should allow people to easily integrate with what they already have. So as a result, we expect the machine learning to be easier to use and more readable for Java developers. Everything that I have mentioned have some issues that you can find in existing offerings. For example, there are, I could say, several machine learning APIs in Java, but many of them are very different, and they don't share some kind of a common API. They keep reinventing the wheel, although they are very similar with each other. They all have different sets of algorithms. When it comes to visual recognition, they are using different imaging libraries, and most of them have native dependencies which have create issues with portability and integration and security. And for average Java developer, some of these APIs look very complex and difficult to use, especially since some of them are basically Java wrappers on top of existing C libraries, and they have kind of a C flavor feel with coding, which is, most Java developers would prefer more modern Java-friendly API feel. So our main design goals and principles when creating this API is to enable Java developers to leverage their Java skills when they do machine learning, and it should be easy to use by non-expert in visual recognition and machine learning domain, because that's one of the challenges that we have identified that starters with machine learning in Java world have most difficulties with. They don't know how to tune which algorithm to choose, how to tune these specific algorithms for specific tasks, and it takes a lot of research and investment of time to get all these things together. Next thing is to make it easy to implement for existing machine learning and imaging libraries. So this API, we provide a reference implementation, which is based on a community edition of DeepNet's deep learning engine, but we are also working with other frameworks and libraries and looking to provide other implementations. One of implementations we already have is implementation by DJL, deep learning engine from Amazon, and we are looking into providing implementation for TensorFlow and some other popular machine learning libraries. And in general, with this approach, we think that we have achieved a reusable design for applied machine learning that is applicable to other domains too. So we want to make API that is easy to integrate into existing applications and easy to use by software developers who are not experts in machine learning. And I think that we have reached a certain point where we can say we have accomplished that. So let's get to the point. When you say machine learning, there are many different algorithms, many different tasks that you can do, but there are three tasks that we have focused on, and which I could say could cover about 70% of the machine learning application that you can find in practice. There are also many more, but we have picked these three. You will see later why to cover it first. So first is a classification task. Classification task is to create a model that will learn how to classify things into categories. Specifically, we want to create models that are able to classify images, but also to classify data objects. So basically, model gets some kind of input, which can be image or some kind of record from a database, and it says to which category it belongs. So it can be fraud or not fraud, credit card transaction. It can be spam or not spam, or it can be different type of images, if, for example, a cat, a dog, a penguin, or something else. So that very simple type of task is, I think it is the most popular type of task for practical application, machine learning applications. Next thing is so-called regression tasks, which comes down to estimating a numeric value of something. For example, the amount of sales, the value of stocks, the number of clicks on a banner, and so on. So basically, you feed a model with some history data, and you want to create a kind of to approximate that unknown function, so you can predict a value of something in the future, assuming that the history will repeat, right? We are looking for patterns in a change of some value. And maybe it is interesting to explain the third one, which is object detection, is to identify specific images, specific objects in image, which is technically combination of classification and regression tasks, where models are implemented so they can classify specific object in image and also to identify a position of specific objects. So now you can understand why are the classification and regression are really first tasks that we picked. So on this image, you can see the high-level overview of the architecture of visual recognition API. And the idea is to enable application developers to use a standard public API, and that they don't care about which engine, machine learning engine is under the hood, which machine learning engine provides implementation of that API. We have achieved that by dividing these visual recognition tasks into two sub-layers, which are visual recognition layer and generic machine learning layer. Now, generic machine learning layer provides commonly used abstractions like classification and regression and data set, which you saw on the previous slide, and which are basically in every machine learning engine out there. But the problem is that every machine learning engine out there has their own classifier interface or regressor interface or whatever. Now, the idea is to create like we have for collections API. We have one list, and when somebody needs list, they very rarely you want to reinvent the wheel and create your own type of list. Maybe sometimes it makes sense, but when you have list, you have set, you have all these abstractions that are being used during the years and developed, and everybody is using that. Now, this is the same idea with this our generic machine learning layer. There are well-known tasks which are used in practice, and we want to provide commonly used abstractions for these tasks. Our visual recognition task, which comes down to image classification and object detection, sit on top of these generic machine learning layer tasks. So we want to classify images, and we want to recognize objects, right? We want to do that on different types of images, because even the imaging domain is very complex, and there are different solutions for imaging in Java ecosystem, and that's the reason why we have created this image abstraction component, because you have buffered image on the AVT, right? And you have on Android, you have a bitmap, a different image class, then there is advanced imaging API. Depending on the resolution and specific application, people are using different imaging libraries. And we want to create an API that will basically solve the problems of using different imaging libraries and different machine learning libraries as a backend, and to provide standard API that sits on top of different implementation. Now, the way we have managed to solve that is to using the Java service provider infrastructure. So we have created service provider implementations. So different machine learning engines can be plugged into this architecture as long as they provide implementation of this service provider interface. And this service provider interface specify the way that model are being built. So when you are using this API as an application developer, you just know that there is component in a backend that performs image classification, and then somebody has plugged that service provider into the system, and you're building a model and using the model for recognition using this standard public API. Now, I won't go into the details, but to be just a little bit more specific about how we made this happen, here is this overview of these three main levels. This is a generic machine learning layer, which includes data set. There is no interoperability between data sets between different machine learning engines. So we hope to at least have some kind of a common data set class, and probably provide some of these basic abstractions like classifier and aggressor and even evaluation interfaces. So it will be easily to swap machine learning component in the system, and easily to compare to see which one performs better. And when a new generation of machine learning algorithms comes, you can just change implementation and change different algorithms without need to change the client code that uses that model. Next level is this visual recognition layer, which is specialization of these abstractions, of these generic machine learning tasks for specific domain. In this case, this is for image classification. For classifying images, we have interface image classifier, which accepts generic parameter which represents an image. And by the way, as you can see, all these interfaces and abstractions are using generics. Thanks to that, you can specify what type of input objects you want to classify and what do you expect as a result. So it makes a very flexible API that can be very application and domain specific, which means readable to end application developers. And then in order to simplify implementation of these interfaces, we use the commonly used technique for Java. We provide abstract image classifier, which is implementation of image classifiers for specific types of images and for specifies also generic parameter, which says which type of machine learning model it is going to use in a backend. And on the third layer, there is implementation of this interface. If we are using neural network for classifying images, we have convention where we say naming these algorithms like image classifier network. It is a neural network for classifying images. So directly from the name of the algorithm, you understand what it does and how it is doing it. So if I would say convolutional neural network, then you will first have to figure out what the convolutional neural network is and how to configure it to do image and how to configure it to do classification task and so on. But in this case, the API does all that from you and give you like meaningful naming on top of it. So, for example, we have abstract image classifier, which is a base extended by image classifier network, which takes a buffered image as an input, and it is using convolutional network for classifying images. So this is a bit, there is much more to it, and I won't go into all the details for these algorithms. You can find more explanation on our wiki page about classification, about regression, about all these image recognition tasks. But this is to have important to have in your mind this global overview, this big picture. And here it is how it looks in practice. For example, if you want to classify images, we'll use very simplified task, which is also Java related. We want to recognize Duke images. So we want to say if what we have on image is Duke or it is not a Duke, it is not non-Duke. So here is the code that does that. And as you can see, we are using this classic builder pattern to create classifier. We want to create image classifier, which classify buffered images. It uses buffered images in input. And for this specific interface for classifying images, we have neural net image classifier. Now, convention is that each algorithm provides static builder methods, which returns a builder to specify different settings for that algorithm. And here we say we want to classify buffered image class, that will be input. We specify image dimensions and some other parameters which are important for training network. I will get into more details about explaining all these, what are all these settings are for. But let's just run the demo now. And you'll see how the model is being built. And once you have created model, in order to use it, you just say classifier.classify image. So we want to classify image, we say classify this image, and we get the result as a map, right? And the map is containing labels and corresponding probabilities that that image is Duke or non-Duke. So let me see, just can somebody tell me, do you see this code? Is the screen sharing working as expected? Anyone? Matthias?
I'm here. It seems to be working.
Okay, thank you. So this is example how the Duke recognition works. This example is available on a GitHub. So here's the image classifier, builder, and here we specify all these parameters. And now let's run this example, and you will see how it is loading images and outputting logging training neural network. Now, in each epoch is a training iteration. It presents all the images it has in dataset and tries to lower the recognition error. You see, the training error is lowering with each iteration, and the accuracy is gradually growing. Now, in order to show you how this training information looks like, let me maybe show you, I just missed that, to show you the dataset. The dataset contains a bunch of Duke images. So you can see here, there are a bunch of different Duke images, right? So there is lots of variation in them. It would be impossible to create some specific rules how to recognize them. But there are, as Frank said, specific patterns of black, red, and white color here. Now, in order to know what is Duke and what is not a Duke, we provide negative examples. So our machine learning algorithms, we don't want to say if there is a blue color, a red color, it could say, yes, this is a Duke. We want to make sure that it does not get trigger recognition if there is some amount of specific color in image. So we generate a bunch of these negative examples, which can be full color, or it can be other objects, or we can just create like some noise of random pixels, because all these images are interpreted as matrices of pixels. We have a file, text file, which contains a list of labels. In this case, we have only Duke label. We don't know anything else. And we have index file, which contains paths to images, right? And list of files and specifying to which type some image belongs. Now, what algorithm does, it feeds this classifier with these images and trying to lower the recognition error for each image. And as you can see, it is not a big data set. In a relatively small number of iterations, it has reached very high accuracy. So this is all you have to do to build image classifier using VisRec, and this is the typical output. So as you can see, a labels file, that's a path to file with labels for categories, image categories or image classes. Training file is index file with different images. Yes, and I forgot to show you maybe the most important thing. This JSON file, which contains network architecture. It is here. So this is architecture of the convolutional neural network in JSON format. With network type, which loss functions, so all these details, which you will learn along the way, but they are pre-configured for specific tasks. So there are some parameters that you can tune and you can change to tweak it for your specific images and application, but most of them are like a reasonable defaults that are good to start with. So this is typical convolutional architecture, where you see convolutional layer, which is basically a filter detection. So let me explain a bit how that works. I will not go too much into the details, but this is a typical architecture of convolutional neural network that sits under the hood, which takes a bunch of these so-called feature detectors, which are like Photoshop-like filters, which are basically small matrices, 3x3 or 5x5 pixels, which are slided along the image, and they through the training process, all these numbers are configured in order to recognize patterns in the images. And each of these channels, as you can see, this first query is input channel, and then this next layer contains a number of different channels which detect different features in images. Then there is a so-called pooling layer which downscales the image. So in order to make it smaller, easier to process, it downscales the image. And then you have, again, you detect features in downscale images, and then again you downscale images until you downscale to a simple array of numbers. And at that stage you perform classification. The network performs classification. So you have a bunch of components which perform feature detection, adaptive feature detection, and image downscaling, after which you perform classification of recognized features, recognized pattern in the images. Now, the big thing about convolutional networks and why there was a big step is because all these steps which are performed by convolutional networks, before them, they have been performed manually. So people were trying to figure out which patterns are best to use in order to get better accuracy with the classifier. Now, the revolution that convolutional networks brought is that this entire process of manually figuring out the patterns are now part of the training process, and they are performed in these feature detectors, so-called convolutional layers. So since they are able to perform on images, deep learning brought this high-dimensional data processing and automated feature extraction. Now, thanks to visual recognition API, you don't have to dig and understand what's going inside. All you have to do in order to get started with the visual recognition in Java is to know which type of image class you're using, what are the image dimensions that you're going to work with, what are the category labels, how you're going to assign them, and then prepare all these files. Now, the most critical part is convolutional network architecture. We'll have some solution for that, but you can start with these provided starter templates to see. Sometimes you will be surprised of how good the results are. There are also training parameters like maximum error or maximum number of epochs or iterations and learning rate, which are sometimes difficult to understand and tune. But again, we provide reasonable defaults in our examples. And with max epochs, you limit the number of iterations that you want to run training algorithm. And with max error, you specify what error threshold before you stop the training. And learning rate, it is really the most difficult parameter and hard to explain without going into deeper explanation how it works. But let's say that it determines what amount of error on output you're going to use to adjust internal network parameters.
So, Zoran,
yes?
can I take a question?
Yes, of course.
So in the image, why did we specify width and height?
Well, because the neural networks has specific the dimension of input. So the way everybody is working is to scale down image to that specific dimension of neural network input. It can be just squashing. There are different techniques that you can use. You can just squash image, and that way you are going to deform it, or you can crop image on some on the center, or you can crop image on randomly crop image on different positions. So there are different techniques that you can use for scaling image to specific size of the input of the neural network, but you have to do that. All the models does that. That's the way how it is being performed.
Perfect. I think that answered the question.
Mm-hmm. Okay. So this VisRec API, the reference implementation of the API is using DeepNet's Community Edition library, and it is a pure Java implementation of the main deep learning algorithms. which includes convolutional neural network and feed-forward neural networks, which are commonly used for these classification, regression, and image recognition tasks. DeepNet's Community Edition is available under LGPL license, and there is also Professional Edition, which provides some higher accuracy and better performance. And also to mention that the Professional Edition includes a deep learning IDE, which provides visual machine learning tools, wizards, and builders, which greatly simplify tuning and debugging your model. And the end result, you can very simply plug into the VisiRec API. And I have a special announcement on this conference. Starting from today, the Professional Edition of DeepNet is available under free development license, and you can go to the download page and get it now. So this is the example of how doing image classification using directly convolutional network using DeepNet's API looks like. And as you can see, you have to deal with setting all these convolutional layers and max pooling layers and so on, and which type of loss function. And the nice thing about visual recognition API is that it's free developer from need to do all of this. You get reasonable defaults, which are commonly used in these types of problems, and hopefully it will quickly get you started, and from that point you can figure out where to go next. Another thing to mention is that we have very good collaboration with the Deep Java library from Amazon, and that they have also provided implementation of VisiRec API, and there is a very nice article published on InfoQ about DJL and VisiRec API. And hopefully we will see more and more engines providing implementation. And I would like to openly invite everyone out there doing some kind of machine learning library to consider implementing this generic API, so we can provide some common standard and make life easier for all the Java developers. So the next steps that would be for you to start with the VisiRec API, it is to go to this getting started guide on GitHub, and you will see explanation of all these different steps and algorithms. And if you're welcome to get in touch with us and join the mailing list and send issues, and let us know what application you have in mind. And the whole point of development of the API is to involve community and create something that will be useful for everyone. So Frank, would you like to say any final words? Frank, are you there?
Can you hear me now?
Yes.
Okay, sorry about that. Physical mute as opposed to soft mute. Yeah, so we have to work on VisiRec for several years, and I think both of us are quite excited about the potential for VisiRec. And with Java and machine learning, Python can't have all the fun. It's nice to have 12 million Java developers now able to at least use for visual recognition. There's certainly other applications for machine learning, but as one of my slides said, we didn't want to build the ocean. We wanted to have a deliverable. So hopefully people will start to use this, and we can make Java a first-class citizen in the world of ML. So I don't know if, Matthias, if there are any questions out there.
Yes, there are a few questions. One is, does any reference implementation have any built-in functions for converting TIFF files to PNG files?
No. It can use JPEG and PNG, buffered image. I don't know if buffered image supports TIFF file, if there is a way. But if you can get these TIFF images in buffered image, yeah, it can work without a problem.
And I should also point out there, if you just Google for TIFF to PNG conversion, I'm sure you'll find like 10, at least a dozen conversion software to do that. So that should be pretty straightforward.
Just hanging in, as you see there. So no more questions in the yet. Regard for professor from a student, Vladimir. So you ordered your students to watch your presentation here.
No, I posted on posted on LinkedIn. So someone probably saw it.
It's perfect. So I guess that is, if you don't have any final comments, I guess this will be the end of the presentation.
Yeah, actually, the only thing I could add is that please visit the website and let us know what you like and what you don't like about the API and how we can continue to improve it. And just please let us know.
Perfect. Thank you very much, and you get some feedback, a great presentation and so on. So thanks everyone for watching. Bye.
Thank you.
Thanks, Matthias. Bye-bye.